So, okay, let me start now. SQL was developed in 1970 by IBM researchers, and since then SQL has been a data standard, I would say. So whenever there is data manipulation, data aggregation, data intelligence is required, SQL is your go-to language. Why so? Because it's a procedural language and has been there for quite a long time, and it's as simple as an English statement that you read. So as we'll move along with the course, you'll get to know like the SQL queries or the statements that we execute are they're very much doing, but they basically sounds like, or what we actually read about them. So let's say there is a statement like create database XYZ, then it's literally gonna create a database with name XYZ, as simple as that. That is the speciality of SQL, that there is no hidden meaning. Contextually, it is very easy to understand. Syntactically also, there is very good documentation available over the internet, and it is one of the very prominent language since 1970s that has been used for data manipulation across the different fields. Now, while we were introducing ourselves, a lot of you said that you're working on big data Hadoop. So while you have been working on big data Hadoop, there must be an engine that you must be using, that is Hive, and there the language that it uses, Hive query language, HQL, which is very similar to SQL. And the reason Facebook created HQL was the same, that there are a lot of engineers knew SQL but did not know the Java program, how to write a Java program in order to manipulate big data. So what Facebook thought is, why not have a SQL-like language framework for our engineers so that they can manipulate big data using SQL programs. Now, essentially what happens in the background of HQL or Hive query language is, it essentially convert your HQL queries into Java programs, which then run on multiple clusters or big data distributed computing. So that's how important, or that's the significance of SQL we have in day-to-day world. Even if we are developing towards big data technologies and distributed computing and cloud architecture and everything, but SQL is gonna stay there for a long time, and it has been there from a longer period. It's been, I guess, 5 decades, you can say. So it's been there for over 5 decades, and it's gonna be there for another 5 decades. I can say that for sure. Now, what exactly is SQL? It's a structure, full form stands for structured query language. As you said, it is a language used for storing, manipulating, and retrieving data in relational databases. It's a standard language for RDBMS system. There are many kind of RDBMS system exist out there. Like someone said they have worked on IBM DB2. Someone said they have worked on big data, so they must have worked on Hive. And then there is open source MySQL. Then there is Microsoft Access. There is Oracle, and then there is finally SQL Server that we'll be using in our course throughout, Microsoft SQL Server. And while we are on the subject of discussing why SQL, what is SQL, I would like you to throw this out there, that there are a lot of SQL flavors out there as of now in the market. And the one we are going to focus on is called T-SQL, Transact SQL, which is a Microsoft SQL flavor. And then the other flavors are like MySQL, NoSQL, and even there is Postgres. Then what else? MongoDB uses its own flavor of SQL. Then there is there are like T-SQL, the one we'll be using. There are many kind of SQL flavors out there, and they are very much same to each other with respect to each other. But at the same time, when we talk about NoSQL and MySQL system, they are very different, and even their context and structure and everything is going to be different. So you can relate T-SQL with all the SQL variants, but not with the NoSQL variants. So NoSQL DBs would be like MongoDB, DocumentDB, Cosmos DB, and Cassandra for big data savvy people. You must have worked on Cassandra, Voldemort, or these kind of different DBs, NoSQL databases where the data is not in a relational database system, but do exist in a key value pair, column store data document kind of database that they are using inherently. Now, why we are using SQL? As you said, that we are using it for data management, database management system. We are using it to describe the data. We are using it to manipulate it. We are doing all sort of data manipulation, data aggregation, data intelligence functions using SQL. Now, how does a SQL structure looks like is something we need to understand. So I'm going to give you a brief overview, and please feel free to interrupt in case if you have any questions. So now onwards, it is going to start being a little technical. So what the way exactly it works is there is a database in which all of these tables or tabular data exist, which is related to each other. The reason we call it as an RDBMS or a relational database management system is because data is related to each other. That is the crux of it. If your data is not related to each other, essentially the system you have is a DBMS, but not RDBMS. It's not related to each other. Now, these tables that exist within a database, you need to access them, right? And I hope you all have a basic knowledge of servers. I mean, how does a server work? So nowadays we are moving towards cloud. Even cloud has at the end, in the backend, they have a data center where the cloud services are also running on servers. But earlier, what used to happen is, or you can just have it on your on-premise or on your local server also. What you need to do is you have to create a local server. Then you need to create a database on top of that. And then within that database, you can create a table or a set of tables, and then you can query those. So essential component in order to query a table would look something like a server on which a database is hosted, in which tables are existing, which we are then querying to retrieve information related to anything. Any questions so far? I mean, if you have any, you can just type in the chat window and I'll take it. So now, what are the essential, the key components of a table is, we are all aware of rows and columns, but here we're gonna basically have a synonymous name for those rows and columns. Rows are gonna be called records and columns are gonna be called fields within a database table. Okay. So now moving forward, when we are talking about records, we are talking about rows essentially. And when we are talking about fields or attributes, we are talking about columns. And the combination of these fields and rows create a table. Combination of such table create a database. And then there can be these multiple database on a single server. I mean, a single server can have a single database also, but it can have multiple database also. There is no any hard and fast rule for that. Now what I'm going to show you is what the system that we'll be working upon. It is called Microsoft SSMS, SQL Server Management Studio. Yeah. So I would like all of you to install SQL Server on your local system so that you can do the hands-on session with us. You can start doing it side by side while I'm explaining through the course, while we are skimming through it in the beginning. And yeah, all in the way it works is we need to click on database engine. Then since I'm trying to connect with a local server, we need to just write the server name. And then there are different authentication types available. First is Windows authentication. This is for our local system generally, and it was used earlier, but it's not that secure. Then there is SQL Server authentication, which is as similar to providing a username and password, and you're good. Then there are these three which you are able to see, Azure Active Directory related. Now the difference between these three authentication mode is Azure Active Directory integrated works with your Windows credential. So let's say if you have logged in with in your office system, right? In your office laptops, you must have logged in with your office email ID. And now if you're trying to use SSMS with your office systems, you can just use Azure Active Directory integrated, and it will take your credential from the Windows and you'll just log in. Voila, as simple as that. Now comes your Active Directory with password. In this particular case, it will take up your username, but you need to provide the password and then the following multi-factor authentication, even if you have like authenticator app or an OTP or anything like that. You can choose either of the options and then you are logged in. And then there is universal with MFA. In this particular case, you need to provide username, password along with MFA, and then you'll be able to log in. So we're going to go ahead with Windows authentication here, since we are going to use a local instance of the SQL Server and database. This is how it looks. When you click on databases, there are different databases. Right now, I have only two, AdventureWorks and AdventureWorks LT. LT stands for lightweight, and this one is a full-fledged system, like a more of a bigger database, and or you can call it as an OLTP database. How many of you are aware of the difference between OLTP and OLAP? Okay, good. I like the honesty. It's good. So I'll tell you. So there are basically two types of system when we're talking about databases, and you can say any kind of data processing units. There are majorly two. You can distinguish between them in basically in two different categories. One is called OLTP, another one is called OLAP. OLTP stands for Online Transactional Processing System, and OLAP stands for Online Analytical Processing System. Now you can think of it that way. OLTP are mostly used by transactional systems, such as banking. Now, you're basically making a credit card transaction or you're buying something online. Banking is involved, right? It is a transaction-based system. And now that entry needs to be happen into a backend database where that record goes that, hey, Jen has basically purchased, let's say, a Louis Vuitton bag from Amazon by using this XYZ credit card at so and so time, and this was the amount deducted or charged on his on a card. Now, this kind of system is something we call a transactional processing system. The difference between them is they need to have a low latency, because otherwise user experience will be very bad, and point of failure is not acceptable. Because let's say, as and when Jin is making the transaction, and if the transaction is not recorded in our backend system and the transaction gets successful, then she has used that money, but it has not been charged on her card, and she has used it for free. That is something we cannot afford, and that's why OLTP system has this inherent property of low latency as compared to OLAP system. Another thing about I'd say OLTP system is they have ACID property integrated with them. And when we're talking about ACID property, ACID is a short form for atomicity, consistency, integrity, and durability. So each transaction is held accountable with all of these four properties. Let's say if there is an incorrect transaction that happened and we need to roll back, database does that for us. It basically rollbacks the whole transaction in case if the transaction is wrong or if it needs to be rolled back to the previous version. That capability is there, and that is something we call atomic. Like it has this particular example has all the four properties in it. I'll tell you how. So let's say there is one record which you entered by mistake, and now you need to roll back. So if you can identify that particular one record individually, there goes your atomicity part of the property. Integrity, you're able to identify that particular record that this is not correct, or this data is not in sync with our system from where it is coming from. So there comes a property of integrity. Then comes the durability, like if you would like to persist that particular record on the database or not, or would you like to commit or roll back to the previous version, like when that record does not exist. And then comes the part of durability. Durability, I mean, since we are in this particular case, we are not persisting the record, durability does not exactly come into the picture. But yeah, if we would be like, if there is a exact correct record in the system, we would like to persist it, and then the durability would kick in into the system. Other few example of OLTP versus OLAP is, you must have heard about databases and data warehouse. Just a second. So the inherent difference between databases and data warehouses: databases are used generally for OLTP system, and data warehouse are generally used for OLAP system. That doesn't mean that you cannot use data warehouse for OLTP or database for OLAP. It's just that inherently that is the standard industry norm we follow, but technological capability wise, you can use this system interchangeably. But yeah, the way they were created, they meant for respective purposes, like database for OLTP and data warehouse for OLAP system. Generally, an OLAP system consists of different many sources. Let's say you will be pulling data from hundreds of different sources. You will be aggregating in a single data warehouse. You will be able to draw business intelligence out of it. You'll be able to create your business respective views. Data will be there for a lot many years, like 10 years of data will be there in the memory. You'll be able to draw analytics out of that, such as what was my year over year growth, QOQ growth, MOM growth, and all of these different kind of matrices from an OLAP system. So in a way, the way they are different is your OLTP system will be just connected to one particular source. Transactional data would be handling. OLAP will be handling multiple source. Huge volume of data would be handled in a data warehouse. Then, since we are not tackling with the transactional system in case of data warehouse, asset compliance is there, but not in the terms of the way it's there in the database as compared to data warehouse. Then there is processing time in OLAP. It is generally more than the database, because you are here trying to query last 10 years of data, maybe. But in case of transactional system, you will be doing things on the fly. And the availability wise, both will be same, both will be highly available. So that's how it looks. I think I'll be able to show you a small example. So think of it as a transactional system where you have all the main tables on your day-to-day basis which you need to use. But data warehouse would something look like this. It has a lot many tables, and a lot of data would be there which will be related to each other, and then and for a lot many worth of years, so that you can get different insights out of it. And that's basically the essential difference between OLTP and OLAP. And then you can, for more specific examples, you can just go out of the Google and yeah, you can have better examples as well. Let's move forward. So yeah, since we connected to the database, now we need to understand how does exactly how does in backend that query is getting executed. So there is a database layer in which our data will be persisted, and this is called the physical layer. Actually, I'll call it, this database exists on a hard disk if it's not an in-memory database. So it will be really like literally existing on your physical storage, that is a hard disk or HDD or SDD, whichever kind of disk you're using. And then on top of that, we have a DBMS engine. Now this database management system engine is something like what we are using as of now. That is Microsoft SQL Server. So RDBMS engine is SSMS, Microsoft SQL Server Management Studios engine, and which is nothing but is named as Vertiback. On top of that, we have a query language processor. So something like, since we have all worked with different kind of languages, you must have heard of interpreter and compilers. Here we have query language processor. We do not have interpreter and compilers, but it is similar to that. It translates your query into the actual code which you are trying to retrieve. And then finally, you have SQL query. So you fire a SQL query, query language processor interprets or compiles it in a machine understandable form. DBMS engine optimizes that query, retrieves the result in the best possible way for you from the database itself, which is holding the data itself. Any questions so far? So what we were trying to essentially understand is, what is the data, difference between data, database, RDBMS, and SQL. This query that we are able to see is a SQL query. this result set that variable to see is the data itself. This instance on which it is stored in a table. This table is stored in this particular database. So this is the database, this is the table, this is a SQL query, and this is the data itself. And the reason this particular database is called an RDBMS is because these tables are related to each other. And we're gonna see in our moving forward slides how exactly that works. But just to give you an overall example, let me show you. I'm sorry, Mayank is asking how to create local server to connect to SSMS. Okay. But I hope others won't mind. And it's I'm glad that Mayank you asked that. Is anyone else facing this particular issue? I think this would do. So Mayank and anyone who would like to install the SSMS and set up their environment, you can download your SQL Server Express Edition from here. This would essentially set up your local server, and then at the end of this setup, you will be getting an option to install SSMS on your system. Since I've already installed this, I can show you the installed instance. Actually, since this is installed, I'll be able to show you these things. So these will be there in your system once you have installed SQL Server Express Edition. That is configurator and usage file. Sure, I can paste the link. Yeah. Let's move ahead. So we understand the difference between database, relational database management system, and SQL. So I'm going to use very interchangeably these particular terms: DBMS, RDBMS, database, because in our context, all are same. Our database management system is a relational database management system. So when we are talking about RDBMS, DBMS, or a database, they are all the same.